With over 900 scientific papers peer-reviewed and 3 decades of Ivy League experience, Avi is the top of his field in astronomy and astrophysics. By one quantitative metric that scientists and scholars use to measure their success, the H index, a value of a 12 is considered good enough to secure university tenure. 20 is a sign of notable success. 40, representative of an outstanding scientist. Loeb boasts a high of 112. Without further ado, Avi Loeb. Avi, you are a theoretical physicist who works on astrophysics and astronomy. All three of those fields have featured some of the greatest minds in the history of science, including the likes of Galileo, Copernicus, Max Planck, as well as more recent figures like Albert Einstein, Edwin Hubble, and Stephen Hawking. Tell me, do you have a favorite scientific mind from the past, maybe even one that inspired you?
Not really. I approach science from a fresh perspective, based on new things that we discover and trying to apply common sense. I don't think of science as a pedestal, as an occupation of the elite, as a status symbol. I think of it as a way of life. And, when I encounter problems at home that I have to fix, I treat it just like a scientific problem. And I think about almost everything in life with a scientific lens, looking at the evidence and then trying to come up with possible interpretations of what it means and how to move forward. So in my mind, the science can be practiced by anyone. And it's a very useful way of thinking about the world because you learn new things if you are open-minded.
Absolutely. And so I find this fascinating because one of the things that I've noticed in a lot of your interviews and a lot of your conversations is you really don't think of science as something that should be about the ego. It's really about how you can figure out what is going on in reality. And this is something that you practice pretty much all the time, yes?
Right. So science is a dialogue with nature. And by dialogue, I mean that we need to pay attention to experimental data, to the evidence in front of us, because otherwise we go in directions that are not really real. Obviously, we can all think that we are wealthier than Elon Musk, and that's a very happy feeling. It's sort of like the feeling that Aristotle felt when he said we are at the center of the universe. It flatters our ego, and we are happy with it. And people believed Aristotle for 1,000 years. We can believe that we are wealthier than Elon Musk for as long as we want. But the point is, if you really want to cash it, you go to the bank, and that's like an experiment. And you find out that the hypothesis is wrong, most likely. And except for, even for Elon Musk, he's equal to himself, not more than himself. And so the point is, experiments are really necessary to educate us about what nature is. And very often we fall into the trap of a monologue rather than a dialogue. And I think in the academic culture right now, people attempt to avoid mistakes. And the biggest risk you can have is putting skin in the game. Just like kids do. Kids put their real skin into the game and they get injured as a result. But in science, if you make a prediction, it might be proven wrong. And, Einstein was wrong 3 times. And in the last decade of his career, he said black holes don't exist, gravitational waves don't exist, and quantum mechanics doesn't have spooky action at a distance. And all 3 were found to be wrong based on experiments. Quantum mechanics was taking us out of our comfort zone. It took Einstein out of his comfort zone. But that didn't mean that we should ignore it. On the contrary, we should adjust to it. We should adapt to it. So when something comes our way that doesn't quite line up with what we expected, we should pay special attention to it. Like a kid, it's exciting. It's something new. Let's find out more about it. Let's figure it out. But instead, this object that we will talk about, Oumuamua, when it showed up, there was a seminar at Harvard, and I left the room with a colleague of mine after the seminar, and the colleague said, Oumuamua is so weird, I wish it never existed. And to me, that's exactly the opposite of where a scientist should be. We should be excited about the unknown and not worry about making mistakes. The thing is that a lot of people in academia are trying to portray their best image so that they will get honors and awards. And because the selection committees are occupied by conservative scientists, and they try to walk in a narrow path and never dare to take any risk or make innovative suggestions. And that's unfortunate, because the whole idea of tenure in academia is intended to encourage people not to worry about their jobs and allow them to be free. But instead, it does exactly the opposite. And I was asked by the Harvard Gazette, which is the Pravda of Harvard University, that one question: what is the one thing you would like to change about the world? And my answer is, I want my colleagues to behave more like kids, taking risks and enjoying, putting some skin in the game.
Right. Is there a path forward in academia to actually get to that point? Obviously, we have an experience now where academia is very conservative, and there is very little skin in the game. How do we actually get to that point? What are the things that we can do in academia to get us to that point?
Well, basically, the reward system should change. Instead of rewarding people just based on their intellectual gymnastics, when they show that they are smart and so forth. I mean, that's relevant for mathematics, for example, where you don't have to match reality. But in physics, you really need to explain the world. So we should reward those people that put skin in the game, that make predictions that are tested, rather than those that make smart remarks or do mathematical manipulations in anti-de Sitter space, a space that doesn't represent the world we live in. The point is, it's not about showing that you are smart. It's about explaining what the world is like. And, it may not require a lot of math. Aristotle's view of the spheres around us in a universe that is centered on us was very beautiful and sophisticated, but it was wrong. So the point is, that nature could be simple, might not need the fancy math, might not demonstrate that the person who discovers the truth is particularly mathematically skilled. But who cares? We're trying to figure out what an environment we live in. And then we can decide how to use it for our purposes. That's the whole idea of science and technology. Technology is using our scientific knowledge. And in the case of searching for extraterrestrial life, it's basically knowing which neighborhood we live in. You come to a town and you want to know who is around. And if you are alone, of course, it changes the entire perception of what you're here for. But then there is a question: if you're not alone, are you the smartest kid on the block, or are there other kids around that are smarter than you?
Right. So you're saying we need to get away from the witty one-liners and really focus on what is the nature of reality, and using that understanding to create better realities for human beings on Earth. So if not for being inspired by any sort of scientist in your past, like, what was it that brought you to science? What was your inspiration? What led you on this path?
Well, as a kid, I grew up on a farm. You can still regard me as a farm boy. People that know me from childhood would say that I haven't changed much. I tried to preserve the childhood curiosity that I had. And I came into science from the point of view of philosophy, from the deepest questions we have, the big picture, rather than drilling down a very narrow niche of technical expertise, which characterizes most of my colleagues.
Right.
The problem with that is, if you take the wrong turn in the highway and you continue to drill along that path, you may not reach a very interesting destination. And so having the bigger picture allows you to navigate and figure out, how to correct yourself and how to find the better path forward. Also, it gives you a better sense of whether the entire endeavor makes sense. If communities of hundreds of people work on a completely speculative notion, even though it's considered mainstream and they give each other awards and prizes, that doesn't mean that it's worthwhile. There was a philosopher that gave a lecture at the annual conference for the Black Hole Initiative, the center that I'm the founding director of at Harvard University. And he said that if physicists agree on something for a decade, it must be true. And I was really surprised by this comment, because Obviously, it's not up to the physicists to decide what is true. If we are trying to describe nature, it's up to comparison to experimental data. And some people lost it in the current culture. And by rewarding those that pay attention to the goals of our profession, I think we can correct path. I think that physicists should basically have an oath, just like medical doctors, in which they state clearly that at least one of the ideas they work on will be testable within their lifetime, because otherwise, what's the point?
Absolutely. And we see this across so many domains, right? We see it in medicine, we see it in science, we see it in technology, where we've got this dramatic over specialization, and there's really little room or effort being put into a sort of universality principle or a theory of everything. How do we get to that point? Like, what sort of institutions, what sort of structures do we need to create in order to begin to look at the big picture and utilize the specialization of science and medicine to get those answers?
Well, you need people that work in the interfaces between disciplines and people that see the bigger picture. And frankly, I also think that humanities have a lot to contribute nowadays, because we're developing new tools, like, for example, in genetic studies and in artificial intelligence, that would affect life and death questions. If your life depends on an AI software, in terms of the decision making that will replace a doctor, a real person, then there are moral issues about what exactly are the decisions that we let the computer make, and similarly about designing, genetics of humans, and if we are able to design people, the qualities of people, there should be boundaries on that. And so I do think that all disciplines that we currently have an important contribution to make to the progress. And people that have a foot in multiple disciplines are very valuable, because they can connect the dots. So a generalist view is extremely valuable, but it's not rewarded in the current system.
Right.
People are rewarded for being focused. And what you end up getting are communities of scientists that are sort of in islands. They're separate from each other. They don't talk to each other. And some of these islands are really in the wrong direction. They're really completely misguided, but there is a big enough community of people doing the same thing that they convince each other that it's worthwhile. It's sort of like a religious cult in a way. And some of these also pursue goals that will never be checked, like there will never be a test that will demonstrate to them that they are on the wrong path. So there is a lot to improve, I think, in the current culture. And I think by changing the reward system, and also the allocation of funds, instead of funds being allocated to mainly conservative projects that the selection committees think that they would pay well for the money spent by taxpayers, it actually is not necessarily the right approach, because even in the commercial sector, we find companies that invest in risky propositions because they know that one of them will outpay for all the failed attempts.
Right.
So there should be a fraction of the budget allocated by federal agencies that goes into risk-taking, encourages people that innovate, the people that do not necessarily think within the box, rather than have the current ecosystem, which is being built around things that we already know. It's boring to continue to do the same, repeat the same mantras we heard. It's much more exciting to look into the new frontiers that can be opened up, and anomalies that we find are one type of signposts that tell us go in that direction, because nature has something new to tell you.
Right.
It doesn't quite line up with what you thought.
You brought up Musk earlier, and you're also talking a lot about ethics. And one of the things that I think is interesting is, you look at somebody like Elon Musk, who's developing Neuralink, and he's developing all these robots to utilize Neuralink to help repair folks who are quadriplegic and things like that. my concern with somebody like Musk is that he views everything through a very tiny prism, in that he wants it's all about Mars colonization, yet he's got a lot of other things that he's working on. What do you think? I mean, is he kind of on a dangerous path? Is he the guy that should be defining ethics in the future of space colonization and robotics?
No, I don't think so. For example, in the context of going to Mars, one of the main concerns is human health, because there is no magnetic field that acts as a womb like we have on Earth that protects us from cosmic rays. And if you were to go there over 1 year, your brain will be exposed to cosmic rays, and a significant fraction of the cells in your brain could be damaged as a result. And obviously there is a risk for sending people there, and we need to solve it. So you can put people in caves, or you can arrange for special structures that may protect them. But it's a problem that needs to be attended to before we make any commercial plans about going there. And I haven't seen such plans. Now, of course, there is a lot of money now in the private sector that can be used for scientific purposes, but it's still important to involve scientists in the decision making as to which direction to take and what are the priorities that we should follow. Because you know, there are lots of subtle issues that only the scientists will be able to recognize, and people that work in the tech industry are used to environments like the Earth, and they don't recognize them.
Right. Let's pivot a little bit. So I want to talk about Oumuamua. This is, the paper that you wrote about Oumuamua that passed through our solar system in September of 2017, which wasn't even spotted until it was until after it passed the sun. I'd really like to, I know you've explained this probably about 1 million times in the past year or so, but could you just give us a quick recap of when you discovered it, what inspired you to really look deeply into it, and what you found?
Right. So this was the first object that was spotted near the Earth that came from outside the solar system. It's sort of going to your backyard and finding an object from the street. Well, first of all, it's a way of learning what's out there on the street, because we haven't seen an object from outside yet. And here is one. And at first, astronomers thought, it must be a comet or an asteroid, the type of rocks that we have seen in the solar system, left over from the formation process. But then it didn't have a cometary tail. There was no trail of gas surrounding it, or dust. So it was not a comet. And in fact, the Spitzer Space Telescope looked very deeply around it and couldn't see any carbon-based molecules, no dust, nothing. And then, in addition, it had most likely a flat shape, not cigar shape, but flat shape, like a piece of paper. It was tumbling over 8 hours, like a piece of paper tumbling in the wind. And the brightness of reflected sunlight from it changed by a factor of 10, implying that it has a very extreme geometry, at least 10 times longer than it is wide, projected on the sky. But then intrinsically, it was at the 90% level, most likely flat, pancake-like. And then there was an extra push on this object in addition to the sun's gravity. And this push could not have been caused by gas evaporating off its surface, because we haven't seen any gas. And so the question was, what causes this push? And the only thing that came to my mind was the reflection of sunlight. And indeed, this force declined inversely with distance squared, just like you expect from the reflection of sunlight from a surface. And it was also a smooth function, unlike cometary evaporation that usually comes in jets that introduce jitter and change the spin of the object. There was nothing like that. It varied smooth. So in fact, just a few months ago, we found another object that showed an extra push from the sun with no cometary tail. It turns out that was a 1966 rocket booster that we put in place. And at first, astronomers didn't know what it is. It was discovered by the same telescope, Pan-STARRS. So they gave it the name 2020 SO. And then it was clear why it doesn't show a cometary tail and why it has this extra push. And it was simply a very thin object, a hollow object. And we know that we produced it artificially. The question is, who produced Oumuamua?
Right. Right. So the International Space Science Institute, they've actually rebutted or attempted to rebut some of the things that you've said. And I would love to get your rebuttal to their rebuts, if you don't mind.
Sure.
Okay, great. So one of the rebuts. So you say that there are too few interstellar asteroids in space to expect Oumuamua. The ISSI team says, well, we don't really know because we don't understand. We don't know what the distribution of interstellar asteroids is. What's your response to that?
Yeah. So in fact, a decade before Oumuamua, we did a calculation of, based on the solar system, how many interstellar objects you expect to exist. And this was a paper you wrote.
This was a paper you wrote, right?
Yes, I wrote it a decade before Oumuamua.
Right.
That was the first paper forecasting the population of interstellar rocks. And based on what we know in the solar system, assuming that other stars have similar planetary systems, and we found numbers that were off by at least 100 up to 100 million compared to what's needed to explain Oumuamua as a rock. And so the mere detection of pan-stars was a surprise. But then one of my collaborators on that paper, Amaya Moro-Martin, she's now at the Space Telescope Science Institute, she wrote a couple of papers after Oumuamua was discovered to try and infer the implications. And she found that, again, when she takes the necessary abundance of objects like that for Oumuamua to be discovered, she finds that the numbers don't make sense. They just are much too large by orders of magnitude than what you would expect simply in terms of the total amount of mass that you need to eject out of planetary systems. And the point is, if you make it a very thin object, then the amount of mass is much smaller. But if you make it a rock that is hundreds of feet long, then it's just a lot of mass that you need to expel from planetary systems. So
right.
in this, the statement that you read, you can make that statement, but if you look at the literature and the papers that I wrote and that Amaya Moro-Martin wrote, they basically show that what this statement says is wrong.
Right. And this is the thing that boggles my mind, is that these folks who are rebutting this, it almost is like it's almost a generic rebuttal because they don't have enough information. So in order to rebut, they just need to say something very generic. Is that kind of your opinion or feeling?
Yeah, well, it was a group of people that came together to just make a statement as if from a point of authority,
Right.
And it reminds me of the story about a book that was written in the 1930s with many authors, tens of them, arguing that Einstein's theory of relativity is wrong. And when Einstein was asked about it, he said, why do you need tens of authors? It's sufficient to have one person that makes a good argument. And so when you see a lot of scientists coming together, it's in order to establish authority.
Right.
But the problem is, science is not dictated by authority, it's dictated by evidence. Once again, a fault of the culture that we live in. People think that you need to get a lot of likes on Twitter. But my point is, listen to what basketball coaches often say. Keep your eyes on the ball, not on the audience. The ball here is the evidence. If you have an alternative interpretation of the evidence, go ahead and write a paper about it, rather than tweet and say, oh, I don't believe this. Someone wrote a tweet that he doesn't believe my book, he doesn't think it's right. And the same person sent me an email just a few days earlier saying he didn't read my book. Oh. So my question is, how can you make a statement like that without reading the book?
Oh, that's got to be incredibly frustrating. So you mentioned something interesting here, and I really appreciate this. You talk about the authority by committee and the ability that some of these folks have when they come together by committee to rebut arguments based on the evidence. And rather than having a good counter argument that's developed by the evidence, you're saying they're just coming together by committee to create a sort of blanket generalization statement that rebuts the evidence. Is that accurate?
And I divide the scientific community into three parts. There is the part that are bloggers, people that write blogs and have popular science books, and they call themselves scientists, but if you check the literature, they haven't published a single scientific paper over the past decade. Some of these people.
Right.
And I don't even read what they write because they are not practicing scientists. I mean, they just pay attention to the number of likes they get on Twitter, and they're trying to be liked. Then there is the majority of the scientific community, that these are real scientists, in the trenches, they're doing work, but most of them are not familiar with the details. They don't study the anomalies that I mentioned, and they don't really care about it. They say, oh, it's probably a rock, I don't want to get into a controversial debate. Let's forget about it, business as usual.
Right.
And then you have the group of people that really pay attention to the anomalies. These are the ones I respect the most because they follow the scientific process, right? They pay attention to the evidence and they say, okay, we want to show that this object is natural. Can we explain those anomalies from a natural channel? Okay, birth channel. And they came up with 3 scenarios. Okay, these people that I respect the most. One was that it's a hydrogen iceberg, a chunk of frozen hydrogen. Because then if it evaporates and you get a cometary tail, you can't see the tail, it's transparent. The problem with that is that a chunk of hydrogen will get evaporated along the journey very quickly. We show that in a follow-up paper, and the authors of the original proposals didn't have anything to say in response. So I think the case is closed. This thing cannot survive. Then there was a suggestion, maybe it's a dust bunny, a collection of dust particles assembled together in a very loose configuration, such that you have a cloud of dust that is 100 times less dense than air. Okay, so just think about something that is 100 times less dense than air, size of a football field, spinning around every 8 hours, and getting close to the sun so that it gets heated to hundreds of degrees. Would that survive the heating? I mean, I find it hard to believe. And also, how would it survive the journey? That's another issue. So, and then there was a third suggestion, the last one, which is a bigger object came close to a star and was tidally disrupted into shrapnel. The problem with that is you would get usually all elongated shrapnel pieces and not flat, pancake shape. And also the chance of coming close to a star is very small. So most of the time you will see objects that never came close to a star rather than. So my point is, these are the possibilities on the table. And of course, it's always possible that there is a natural birth channel for such an object, and we haven't thought about it. It's always possible. But as scientists, that's the scientific process. As scientists, we put all possibilities on the table. We look at which one appeals the most. And then we collect more evidence and try to figure out, and rule out other alternatives. So why would we take out the artificial origin off the table if the alternatives have such problems? I just follow the scientific process, and all of my critics never attend to the anomalies and try to explain them from a natural birth channel, and they never discuss the fact that all the alternative explanations for a natural birth channel have these difficulties that I just pointed out. That's a honest scientific debate. Like, for example, we don't know what the dark matter is, okay? So people came with suggestions, and then experiments were funded at hundreds of millions of dollars to search for specific types of dark matter. Nothing was found as of yet. So all these hundreds of millions of dollars are gone. We didn't gain much knowledge. We just ruled out some possibilities. Why can't we spend some money on searching for technological signatures in the form of relics, just placing cameras within the orbit of the Earth around the sun.
Right.
And the next interstellar object that comes over, let's take a photograph and see what it is. Now, the way that my colleagues behave, they basically argue, it's never aliens. Show me extraordinary evidence. Now, when they ask, show me extraordinary evidence, they don't provide the funding to show that evidence. They discourage young people. Young people are really afraid when they see this going on because they say, what will happen to my job application if I get engaged in such a search? As a result, it's just like stepping on the grass and then claiming, look, the grass doesn't grow. Right. It's really unfortunate that people don't see that we are putting blinders artificially around our eyes and not looking out.
Right. So we're putting blinders in the form of taboos on the scientific community. And you brought up a really interesting point here. And that point is that the alternative explanations to explain the anomalies of Oumuamua are all theoretical objects. So in a space artifact would be a theoretical object. So would a hydrogen, what did you say? A hydrogen iceberg or a dust bunny. So it's okay in the scientific community to postulate theoretical objects as long as they are not alien technology or an artifact of an alien civilization.
That's exactly the thing. You touched on it. And why would there be a taboo? Okay, so then we get to the question, and the one possibility is because of the science fiction literature and because of UFO reports, and the scientists want to distance themselves from those discussions. But my point is, if you go back to the Dark Ages and people were saying you shouldn't dissect the human body, that you shouldn't have an operation because the human body has some magical powers and there is a soul. Imagine if scientists would say, oh, there are all these ridiculous statements being made about the human body. We don't want to discuss it because of the literature. I mean, where would modern medicine be today? I mean, science must address, especially a question that is of public interest. You know, the public is extremely interested. The public is funding science. We have an obligation, not only to attend to the public interest, but to pursue this question because it would have a huge impact on society. I call that Oumuamua's wager in my book. Because the consequences would be so great, you know, we need to put the resources to explore this question.
Right. And so your other point about extraordinary theories require extraordinary evidence, the fact that we're not putting the energy, because of the taboo, we're not putting the time, energy, money into this research. So there's really no way to come to that evidence as long as we're not putting the time, money, and energy into it.
Exactly. It's a self-fulfilling prophecy. You basically say, I need extraordinary evidence, but then you don't allow for that to happen, and you will never see it. So it's just like the philosophers in Galileo's days that said, we don't want to look through your telescope. We know that the earth, that the sun moves around the earth, and they put him in house arrest. The point is that didn't change reality. Reality doesn't care whether we ignore it, and the earth continued to move around the sun. So we can bury our head in the sand, you know, and not look out. And in principle, you know, we might think that we are the smartest kid on the block, just like my daughters thought that they are the smartest kid on the block when they grew up at home. But when they went out to see other kids in the block, they realized that this might not be true. And unfortunately, you know, if we don't look for wonderful things, we will never discover them. And to me, just figuring out who is in my neighborhood is the fundamental aspect of my existence. You know, I just want to know how many kids live in my neighborhood and whether they're smarter than I am, because I can learn from them. That's the very least I can do, or I can learn from their mistakes.
Right. This is a more philosophical question because you brought up this idea that reality and nature doesn't care what we think. But in quantum theory, in quantum mechanics, isn't there this ability for the observer to have an impact on the actual nature of reality itself?
Well, I wouldn't call it the impact of the observer, but the fact that the observer knows the answer impacts the later measurements. And a very deep philosophical question as to what is the interpretation of quantum mechanics. But one thing is clear, that when an observer looks at a system and finds the system to be in and measures something about the system, it changes the system. Okay, just knowing something about the system changes. So then the question is human knowledge or the observer knowledge affecting the system, or is it that the system includes the observer as well in some sense? These are deep philosophical questions. You know, the nature of quantum mechanics is not clear yet, and it takes a lot of people out of their comfort zone, including Einstein. It took him out, and it just like it took Oumuamua took out my colleague from his comfort zone. And nature is not supposed to leave us happy. You know, it could educate us, tell us what you thought about is not really the reality that you live in. And the only way for us to find out is by listening to nature. You know, we should be modest. I think the biggest message I got from studying astronomy, if someone would ask me, okay, what have you learned over the past few decades? I would say a sense of modesty. You know, in many ways, we are so small. The universe is so large. There are so many Earth-Sun systems in it, more than the number of grains of sand on all beaches on Earth. And we live for a very short time, less than 1 part in 100 million of the universe age. And so, you know, we are just like spectators that enter a stage without anybody giving us a script. So we look around and we try to figure out what is our role here. You know, what's the meaning of life? That's the fundamental question. Is life worth living? What's the meaning? And then, you know, that's the one thing I would like to ask an alien. You know, do you know what's because we apparently don't know. And it may well be that it's just, you know, eating good food, having friends. But to me, the most enjoyable part of being alive is understanding nature, understanding where we live, and figuring out where we, you know, our environment. And it's not so much about me, you know, being an important component in the universe. It's about me being able to understand what is going on around me. And because we were not given a script, you know, if we had a script that tells us, you know, 70% of the matter in the universe is this type of particle and the rest are no, but we are trying to figure it out, and we don't know what 70% of the matter in the universe is, or you know, or and so it's fun, you know, and the way to look at it is like it's an adventure. Science and living are an adventure. The thrill is from finding unexpected things, rather than the exact opposite approach that says the thrill is from you know, boosting our ego and basically showing that what we knew before is valid in the future. You know, that is a very boring, I mean, even though you can get prizes for that approach, it's a very boring life. I enjoy, you know, just like climbing the Himalayas, you know, I enjoy the thrill of, you know, taking some risk and trying to figure out something new. And Oumuamua gave me this opportunity, this golden, and, you know, the only reason that the two of us are speaking is because my colleagues do not behave like me. I mean, by the way, I should tell you one more thing. I don't think that I have anything special. I just apply my common sense, and I'm often struck by the fact that, you know, I'm trying to say something that looks obvious to me. You know, it doesn't take a lot of effort. I just say it, and then for some reason nobody else said it, and that's what surprises me.
Right. Well, and it's interesting, and I appreciate your humility in this, and I think that it's diametrically, it's fundamentally opposed to human psychology. We have always been in the position where we believe we are the smartest creatures on earth. We believe that we have the answers before we have them. We'll burn people, we'll kill people, we'll murder people who have differing philosophies from us. And we have this enormous bias towards the masses, towards what everybody else thinks. Yet science is quite literally, the entire point of science is to get away from that, to study the nature of reality beyond the ego, beyond what human beings believe they are and what they know.
But you know, the point is that the science is done by scientists,
humans.
And that's exactly, and that's where you get all the faults into the system.
Right.
And unless scientists are warned not to go in paths that are not shaped by evidence, I mean, they can go in directions that are completely off track. I mean, look at all the religious cults that you might find, or people with political ideologies that are very extreme, or racism, or, you know, people can have ideas that are completely off, that make no sense whatsoever. You know, racism in particular makes no sense scientifically. You know, it's completely ridiculous. And the only way to avoid those mistakes is to stay modest from the beginning. And not to believe that you are superior to another human being, not to believe that scientists are superior to the public and therefore they should never tell the public what they are doing until they are sure. And then they appear in press conferences and make the announcement, and then they retract the announcement in some of the press. So all of this is completely, you know, it's not natural. And what I'm trying to do is just like a kid, that said that the emperor has no clothes. Science is work in progress. And a lot of time it's done by iterations because you don't have enough evidence. And let the public know it, because once you have enough evidence, then the public will believe you. Otherwise, the public would say, oh, maybe the scientists are making something, are cooking something that we don't know about behind the closed doors. And I think it should be completely transparent. And I think of science as something that anyone can understand. Anyway, if you explain it clearly, in simple terms, without fancy math, why should it be so complicated? I mean, a lot of people use technical jargon in order to distance themselves from the public. That's exactly the opposite of what we want.
I want to ask you a fun question from your childlike mentality when it comes to discovering things that are new or kind of postulating on philosophies. Let me ask you this: does the idea that an advanced alien species, if Oumuamua were an alien artifact, and maybe they're observing the human species or sending probes out throughout the universe, sending this through interstellar space that could, and this travel could last millions of years. Do you think that indicates that faster than light travel is not possible?
Well, I would go the other way around. We don't know of a way to travel faster than light. I mean, there are people talking about wormholes connecting distant points of space through a shortcut. But we haven't been able to demonstrate that these things really exist. And particles that travel faster than light have never been detected. Okay, so when we do experiments, we've never seen a signal propagate faster than light. So at the moment, science says you just can't travel faster than light. That was Einstein's original conjecture based, his theory of relativity. You can't travel faster than light. And so if we see something unusual, it may give us a hint that we don't fully understand nature. And that's one thing we can learn from. If they develop their science millions of years ahead of us, it may feel like cheating in an exam, looking over the shoulder of the student next to you. But if it saves us a million years, it's worth it.
Right. Absolutely. And so, I mean, what is your vision for the scientific community over the coming years? I mean, you're taking a real stand here. You're putting yourself as a target, and you have been targeted. And so first of all, how do you deal with that? And second of all, what are you trying to push here when it comes to your ability to push the scientific community towards a more childlike, honest, open debate about the possibilities beyond what the taboos are?
Well, it's very simple with respect to Oumuamua. I basically focus on the ball rather than the audience. I don't have any footprint on social media. I don't care how many likes I have on Twitter. I basically focus on what people make of the anomalies. And, there were these three suggestions that I mentioned, and I have difficulties accepting them. And as a result, I maintain my position about this being an artificial origin. Now, if someone would come up with a scientific paper that illustrates that all of these anomalies can be explained by a natural birth channel, then, that would be very appealing also to me. I'm completely open-minded on that. And of course, if we get more evidence on future objects, that they resemble Oumuamua in terms of their weird properties, and then we get a photograph that shows that it's a rock, but a very strange rock, fine. I will, say I was wrong about thinking that it's artificial. That's part of my learning experience, and I'm willing to admit mistakes. But blocking off directions ahead of time when the alternatives are not appealing makes no sense. And it's not up to those people that make personal insults or make general statements on Twitter. It's up to whatever nature is, irrespective of what they say. We have to focus on the evidence. It's very simple. I just follow the path that a scientist should follow rather than have a prejudice. And it's really surprising to me that a lot of my colleagues did not learn history, a lesson from history, where a lot of times people had the preconception that was proven wrong. And that happened many times, even in recent history. I gave a lecture about gravitational wave astrophysics in 2013 and to a winter school full of students. And one of the lecturers stood up after 10 minutes into my talk and said, why are you wasting the time of these students on a subject that will never be important during their lifetime, during their career. And 2 years later, the LIGO experiment detected the first gravitational wave signal, and the Nobel Prize was awarded, and now it's a celebrated frontier. And this person that criticized me was younger than me by 20 years, and he was a faculty that was expressing the mainstream view that this is speculative and shouldn't be this. And my point is, we should be a little more tolerant. If we want the public to be exposed to the world of ideas, how come we don't allow this world of ideas to develop in the first place?
Right.
And there was this other example of exoplanets. In 1952, there was a proposal by an astronomer, Otto Struve, that perhaps there are some stars that have a planet like Jupiter close to them, and then we can easily detect the existence of the planet because it would tag the star back and forth and sometimes block a little bit of its light. And time allocation committees on telescopes didn't give any time to search for such system because they said, we know why Jupiter is so far from the sun, and there is no point in wasting telescope time. But then in 1995, the first such system was discovered by chance, and the Nobel Prize was awarded for that. And the whole field of exoplanets, planets around other stars, was opened as a result. And people would say, okay, well, what's the problem? Science eventually got to that point. My argument is that we lost 4 decades.
Right.
Okay? And science could have been more efficient. And also, this baby was barely born after 4 decades. Imagine all these babies that were never born because they were blocked altogether. And, it's just unfortunate that you have that in the scientific culture. And I really wish that we would be a little more, how should I say, loyal to our obligation as scientists.
Right. Absolutely. One of the most fascinating, and I really appreciate that, because that is exactly where science needs to go. We talked earlier about the universality principle, the theory of everything. Unless we have connections across domains that are encouraging curiosity, encouraging bold questioning, and encouraging new theories, we're going to be massively inefficient when it comes to science's ability to propel the human race forward. And I think that's
and it's worse than that. You see, I have a student that is brilliant. He was selected to just a few months ago to 30 under 30 by Forbes magazine, and he's only 20 years old. He's the youngest that got it. Brilliant. And we wrote a lot of papers together. And after he saw some of the tweets over the past week, he said that he's having a second thought on whether to do science, because he sees how the senior people are behaving. And, that is unfortunate, because you are discouraging young people from innovating. And usually young people come without the baggage of prejudice, and those are basically the target audience for whom I wrote the book, because I have hope that the younger generation will change the landscape, of our scientific culture. But when they see the behavior and the bullying that is going without, if obviously I would very much enjoy having a dialogue with someone that talks about the anomalies, that have a honest scientific dialogue through the scientific literature, or someone that talks with me about the anomalies and explains them in a different way. That's the way the scientific process is progressing. But unfortunately, it's not like that.
Yeah, it is incredibly unfortunate. And I know you got to go here, Avi, but I have one more question for you.
You can ask me a few more questions.
Okay, great. One of the most important things or one of the most fascinating things that I've found about your hypotheses about Oumuamua was the non-gravitational acceleration, and how, it just can't be explained by existing models unless there is, kind of a solar push. Can you explain to me, what exactly that is, and what we're seeing, and why that's such an anomaly?
Right. So usually for comets, you can get the rocket effect, meaning that if gas evaporates in one direction, it pushes the rocket or the rock, in the case of comets, the other direction. That's momentum conservation.
Right.
And in the case of Oumuamua, there was no evaporation. So you couldn't get that effect. And in fact, if it were a comet, it needed to lose about 10% of its mass, about a tenth, which is a lot. You would easily see a cometary tail if the object loses 10% of its mass this way. And therefore, it's not the rocket effect. So what else? The only thing I could think of is reflection of sunlight, which is just like this rocket booster that showed the deviation based on reflected sunlight. And
right.
Because it has thin walls. So for that, you need a large surface area for its weight. So that because the surface area tells you how much push it gets. And obviously you want to minimize the weight that it carries, because otherwise the push will not translate to a significant change in the speed. And so you end up with something that is very thin, like a sail. And a sail on a sailboat is being pushed by reflecting air molecules or wind. Here it's the particles of light that are bouncing off it, just like billiard balls, and giving it a kick when they get reflected. And this technology of a light sail is currently being developed by us for space exploration. It offers the advantage of the spacecraft not needing to carry the fuel with it. So spacecraft can be very lightweight, just surfing on light. And I'm actually leading a project called Starshot, whose goal is to visit the nearest star, Proxima Centauri, within a couple of decades after launch. And to do that, since the nearest star is 4 light years away, the spacecraft needs to move at a fifth of the speed of light. And the only technology that can do that for us right now, in principle, is pushing a sail by a laser beam, shining on it, because the laser has particles that move at the speed of light, and they can chase a spacecraft even if it moves at a fraction of the speed of light. And we showed that, with a powerful enough laser and a lightweight sail that weighs only a few grams, roughly the size of a person, you can reach a fifth of the speed of light. And we are currently working on developing this technology. So it's possible that other civilizations have mastered this technology by now, and they use light sails quite a bit. And in principle, you don't need a laser to reach the speed of light. And as I talk in my book, you can park light sails around a star that is about to explode. And then when there is a flash of light from the explosion of a star, that will push those sails, just like surfers on the beaches of Hawaii. They're waiting for a big wave to carry them. And here the wave is a wave of light, a flash of light that carries those sails up to the speed of light almost, if they are parked within 100 times the Earth-Sun separation of the explosion. And so then they would travel throughout the galaxy, and that's a natural way. It's like dandelion seeds that are blown in the wind.
Right. And if we're imagining the potential for an alien civilization to do this, it's quite fathomable considering the length of time that the universe has existed. And for us, I mean, as you mentioned earlier, we're human beings. We're here for 70 to 80 years, and we just don't have the capacity to think so far beyond ourselves. We have no idea what sort of civilizations may have existed before us, may exist concurrently, and how far off they are and what they would potentially be capable of doing. If that were the case, Avi, what would you say? Like, if this were, let's say this was a light sail, let's imagine this was seriously an alien civilization collecting data on us. What would you, like, you're developing these sorts of technologies now when it comes to light sails, what sort of system would need to be in place? If this were a light sail, what would it need to what would need to be on board in order for it to signal back to, the place where it came from, what information it's gleaning?
Well, it needs to have a camera and a communication device. But most of the stars in the Milky Way galaxy, in our galaxy, formed before the sun. And that means, billions of years before the sun. We are relatively late comers.
Right.
And just like we are on Earth, we're currently living on Earth that was inhabited by past cultures. And they left relics behind. We cannot speak on the phone with the Mayan culture. They are not around anymore. So speaking on the phone would be equivalent to trying to detect a radio signal, which was the main search method over the past 7 decades, and that makes sense only if your counterpart is alive at the time that you are receiving the signal,
right.
At the time that he transmitted the signal. But most cultures must be dead by now because billions of years passed. And the equipment they sent into space, the equivalents of Voyager 1, Voyager 2, New Horizons that we are sending out of the solar system, those things are billions of years old. So just imagine Voyager 1 being a billion years old. It will be just trash, equipment that is not functioning anymore. And so if we were to look for the plastic bottles on the beach, the beach has mostly rocks that are naturally produced, but every now and then there is a plastic bottle that indicates a civilization. If we look for that, we would mostly find those plastic bottles that are punctured, they are not really functional, they are just space trash. And that's our way of finding evidence, just like with the Mayan culture, through space archaeology. And right. I think it's a completely new frontier that is opened up by discovering Oumuamua, and that we should follow, because looking for radio signals may restrict our attention just to those that are alive at the moment, and there may have been many more, numerous more, that are dead. And by finding those relics from dead civilizations, we can first learn about what they developed, what kind of technologies, learn about them, but also perhaps figure out why they died, if we can trace where these things came from. If we can put our hands on equipment. And by the way, this is possible because, some of these objects will collide with the Earth, and they would appear as meteors, and they eventually land on the ground if they are bigger than the size of a person. So then you can put your hands on it. You can find objects that the moon collected on its surface. The moon is just like a museum, collecting everything falling on its surface. It has no atmosphere that will burn up things like meteors burn up. And we can also search for objects that were trapped in the solar system in the past, and it's just a new way of searching for other civilizations that I think I only thought about as a result of Oumuamua. So in a way, it opened my eyes, and other people that put blinders on their eyes may not see anything for a while, but I hope that the younger generation that reads my book will bring a better future.
I really hope that the younger generation that reads your book will bring that better future. And my last question for you before, and I want you to be able to make sure that you tell people where they can find your book. But Seth Shostak he postulates that if there are ETs, they would be post-biological sentient beings. Is this something like you've considered when it comes to this potential alien artifact?
Yeah, so the point to keep in mind is travel in interstellar space takes a long time, and humans are not really designed to do that. And equipment is much more natural. So if you were to excavate a random point in space, just search around, I think most likely you will find the equipment. And potentially Oumuamua was one, right? And so I don't think you will find biological stuff, we will not have contact with intelligent beings for a while, because it takes a long time for the travel. Also, it's not clear that we are that interesting. When I met my wife, she had a lot of friends that used to think that a Prince Charming on a white horse will come over and make them a marriage proposal, and that never came. And why would we worry about Fermi's paradox? That's a bit arrogant to think that, we are sufficiently interesting for someone to show up at our front door. Why would anyone care about us? We are out there in the dark. We might be one ant out of a billion ants that are on the sidewalk. And we are not particularly interesting. And, it's a sense of self-importance that keeps coming up all the time, thinking that the universe centers on us, and then thinking, oh, okay, but maybe we are unique and special. Maybe there is no intelligent being out there, and you need to give us extraordinary evidence before we will even discuss the possibility of technological signatures. Where is that sense of privilege coming from? You know, like the only way I understand it is that just like my daughters, before they went to the kindergarten, they were not mature. And so a lot of these scientists or general public people that think that we are unique and special and that we deserve a visit and that we are at the center of the action, like we are center stage, are not mature, I must say. That the only way for them to get mature is if we take a photograph of an object that really doesn't look like a rock. So my hope is I will not need 66,000 words to convince my colleagues. If I have a photograph, a picture is worth 66,000 words that are in my book.
Absolutely. I always find it fascinating, this idea of, you know, we wouldn't be that interesting to alien civilizations and alien cultures. I mean, you look at, you know, human beings, as you said, you look at an ant and very few people do anything but step over that ant. But there's that curious kid who's fascinated by that ant who will spend their whole life on the ground looking at it through a microscope. Right. You know, so I always think of that.
Yes, but what you need to think about is, okay, that kid indeed is doing something different, but that kid is examining only a small fraction of all the ants that are out there.
Right.
And therefore, the chance of you, if you are an ant, the chance of you being examined by a kid is really small. It's true that some ants are being examined, so perhaps we have some places where they have contact and with each other, and but the chance, just as a random ant, the chance of seeing a kid in front of you is small.
Absolutely. Avi, thank you so much for your time today. It was truly a pleasure getting to spend it with you. Can you tell folks where they can find your book and how they can find you?
Well, first, thank you for inviting me. I had a wonderful time. It was one of my most enjoyable interviews so far. And I had almost 200. So that's a great compliment.
Thank you.
My book is available in any outlet that sells books, in particular are Amazon or Barnes and Nobles, and you can order it now. It's in the first week after its publication, it's listed number 7 on the New York Times bestseller list, between Michelle and Barack Obama.
That's fantastic. Avi, truly a pleasure. Thank you so much for what you're doing. Thank you for inspiring the kids to become scientists. I really appreciate what you're doing. And I really am fascinated by this Oumuamua concept of what you've introduced. And I really think that if we're going to do our jobs as, I'm an interviewer, but if scientists are going to do their jobs, they have to do it with an open mind and get rid of that bias. So thank you again for joining me, and we'll talk to you soon.
Thanks for inviting me.
Bye-bye.